All right, here we go. Lesson 9 practice problems. Your athlete, Vlade Divac, gives me a chance to talk about the Lakers. Not because Vlade was on the Lakers, but Vlade got traded. He also, let's see, what year was this? 1990. Okay, so Lakers drafted Vlade Divac, right? He was on the Lakers for a few years. And then somebody came along named Kobe Bryant. And Kobe was drafted, I think, by the Charlotte Hornets. Can't quite remember. But anyway, Lakers wanted Kobe, so they traded Vlade Divac to get Kobe. Then Vlade got traded to the Sacramento Kings. And the rivalry between the Shaq and Kobe Lakers and the Sacramento Kings with Vlade, Chris Webber, Doug Christie, Mike Bibby, Peja Stojakovic. Anyway, it was one of the best rivalries in like the late 90s, early 2000s. That was the signature Robert Horry shot. That was the alley-oop. Actually, no, that was the Blazers. But the Robert Horry big shot against the Sacramento Kings. Look it up. It was awesome. Huge rivalry. Lakers, Kings. Vlade Divac was a big part of it. All right, here we go. Lesson 9, practice problems. What is the length of segment DF? Okay, so this one's pretty easy. You got to figure out what these missing angles are. So this one right here is, so you got 68 plus 44 plus, we'll just call it x. It'll equal 180. That's how you need to figure out what x will equal. So 60 plus 40 is 120. 8 plus 4 is 12. So that's 132 plus x equals 180. Just subtract 132 to both sides, minus 132. This cancels out. You get x equals 48, I believe. Let's see. Yeah, 48 degrees. Okay, so this one's 48. That means that this one's 48. So we got all three angles are the same. That means that they're similar. So ABC is similar to DEF. The reason I found 48 is because I want to figure out which sides correspond. So between the, we're trying to find DF right here. So we'll just call that Y. So we're trying to find DF. Now you got to find the 68 and the 44 over here. So the 68 and the 44 is 8. You're going to put it over a Y. So 8 over Y will equal, here's the 68 and the 48, 6 over 18. And if you want to pause your video there and solve for Y, then you'll have DF. But anyway, you're going to get 6Y equals 18 times 8, which is 80 plus 64. 80 plus 64 is 144. Divide by 6. Divide by 6. Y should equal 24, I believe. All right? These 6's cancel out. So Y equals 24. DF equals 24. So you just set up ratios of corresponding sides and then cross multiply. All right, in triangle ABC, angle A is 35, angle B is 20. That means that angle C equals 55 plus 125, 125. Right? Yeah, okay, so angle C will equal 125. How do I know that? They all add up to 180. So that's just the triangle sum theorem. Okay, so select all triangles which are similar to triangle ABC. So we have angle A equals 35, angle B equals 20, and angle C equals 125. So we're looking for any triangle that has 2 out of 3. 2 of 3. You need a triangle that has 2 out of 3. Why? Because of angle, triangle, similarity theorem. That just states that if you have 2 triangles with 2 pairs of angles congruent, then the 2 triangles are similar. That's what that means. All right, in 2 triangles, if 2 pairs of angles are congruent, then the 2 triangles are similar. That's the angle, triangle similarity theorem. All right, DEF 35 and 20, that's good. GHI 35 and 30, nope. JKL 35 and 125, yep. 20 and 125, yep. And 20 and 30, no. So all you had to do is find 2 out of 3, and then you're good. Answer's ACD. All right. Number 3, decide whether triangles ABC and DEC are similar. Explain or show your reasoning. For this one, you need to use triangle sum theorem. So triangle sum theorem to find the missing angle. Meaning 36 plus 21 plus x equals 180. And 123 plus 36 plus y equals 180. We'll call this x, we'll call this y. If you want to pause your video, solve for x and y without my help, this would be a good time. So, all right, so 36 plus 21 is 57. 123 plus 36 is 159. Okay, plus x equals 180, plus y equals 180. Subtract 159, subtract 57. 180 minus 50 is 130, plus another 7 is 123, so x equals 123. So this is 123 degrees. These are out of here. This is 21. So y equals 21 degrees. All right, now these are all definitely similar. So, or these 2 triangles are similar. So because the triangles have 3 pairs of corresponding angles, congruent, they are similar. All right, number 4. Lynn is trying to convince Andre that all circles are similar. Help her write a valid justification for why all circles are similar. All circles have the same shape. And we can envision a circle dilated, bigger or smaller, because the radius is simply scaled up or down. By a scale factor. So all circles have the same shape, and we can envision a circle dilated bigger or smaller because the radius simply scaled up or down by a scale factor. So all circles are similar. Let's skip this one. This was a lesson we didn't cover. Number 6. Determine if each statement must be true, could possibly be true, or definitely can't be true. Explain or show your reasoning. An equilateral triangle, which looks kind of like this. Not perfect, but that's okay. 60, 60, 60, and a right triangle. They're similar. Similar implies same shape. Angles do not change. Forget the sides, let's just look at the angles. And specifically this one. If I have a 60, 60, 60, how am I ever going to get a 90? Right? So this is can't be true. So a right triangle will never be similar to an equilateral triangle. Okay. A right triangle and an isosceles triangle are similar. This would be, well, let's look at this one. If these were 45, 45, 90, then these sides would be congruent. So a right triangle can be an isosceles triangle. But let's show an example that's not. So this isosceles triangle, not a right triangle. So this is an example of one where it would work, and this is one where it wouldn't work. So a right triangle and an isosceles triangle could possibly be similar. So this one could be true. All right, quadrilaterals Q and P are similar. What's the scale factor of the dilation that takes P to Q? I'm just going to use this side and this side. These are obviously corresponding sides. So P to Q, 4 to 5, it's got to be 5/4. You just find corresponding sides and determine is it 4/5 or 5/4, and because Q is bigger than P, it's 5/4. 5/4 is greater than 1. That's the one you want. Okay, one more and then I think we're done. Circle centered at Q is a scaled, circle centered at Q is a scaled copy of the circle centered at R. Find the scale factor. Okay. So, scale factor is 4, because 5 times 4 equals 20. Find the value of x. I haven't taught you Pythagorean, but might as well do it now. Let's just go a squared plus b squared equals c squared. C is the longest one, and it's always opposite the 90. So this is going to be 5 squared. And then a and b are the other two sides. So 3 squared plus x squared equals 5 squared. So 9 plus x squared equals 25. X squared equals 16. Take the square root of both sides. X equals 4. So there you go. All right, that was lesson 9. We'll really dive into this next. So even if you didn't understand that, we'll get to it. All right, 14 minutes, no big deal. And knock out the homework and keep going. Okay, bye.